In this video, I'm going to show you how you can edit the current tools that are in SheetCam or add some more. When you start up SheetCam, the center section here has your tools. To edit any tool, you can simply double-click the tool and all the information about the tool comes up in this dialog box, which you can change if need be and then click OK. There's also a tool table editor. Some people like this because it's in a chart format, so you can compare things, or maybe using the tab key, it's quicker for some people to make a lot of changes. To create a new tool, we just click on the Create a New Jet Cutting tool. First thing we're going to do is give it a name. I typically name the tools with the material thickness, the type of material, and the amperage being cut at. I feel that's all pertinent information. If many materials such as 10 gauge is a crossover material, it can be cut with 45 amp fine cuts, 45 amps, 65 amps, or 85 amps. So having the amperage number in there along with the material is a very handy thing. So we give the tool a name and we pick what type of tool it is. Plasma, flame, or plate marker would be the only three that would relate to an LDR motion systems table. Tool number, it's going to default to the next tool number in line from the last tool we looked at. You can put your numbers in any group that you would like. A lot of people will group 1 through 30 steel, 40 through 60 aluminum or stainless. You can put any number in here that is not currently being used. Kerf width, feed rate, all of this information, almost all of it, comes directly from your plasma cutter manual. In this case, we're entering information for a 65 amp machine, so we would use our 65 amp manual that came with the Hypertherm unit. The 65 and 85 are actually the same manual. We want to go down to use shielded consumables. Unshielded, the consumable life is shorter. They're typically used for anything we have to fit into a tight space, like a beam processing machine or something of that nature. On flat plate cutting, shielded is the way to go. So we have to make sure that we're looking at the right chart. So we have 65 amp shielded consumables, which means any tool that we enter with the information in the charts contained below this needs to have these consumables installed. So we scroll down, we can see that we have our mild steel in both metric and inch, which those are already currently entered in SheetCam. We have our stainless steel, we have our aluminum. So let's use our example of a 1/4 inch aluminum. You can see that our torch to work distance is 60 thousandths. Our initial pierce height is 150. Our pierce delay is 1/2 second. Best quality cut speed is 105 with a feedback voltage of 131. So we would basically want to enter all of this. So our feed rate was 105. Our pierce delay was 0.5. Pierce height is 0.15. Plunge rate. Plunge rate is not in the user manual for the Hypertherm cutters. We have good luck running around 75. I'm going to be honest, I haven't noticed, except when you go extremely slow, I haven't noticed any advantage to whether it be 50 or 80. Really thick materials where we're pushing the limits will actually drop this down at around the 30 mark, but I would run it at 75. Cut height is 60 thousandths, which we have. Pause at the end of the cut. I recommend having at least 1/2 second. The longer the pause, it doesn't hurt anything, it just wastes time. But I do like to force it to have a pause at the end of the cut because things can happen so quick and that there is a time delay from when the computer shuts off a plasma cutter till it actually, the arc is fully extinguished. We have found that 1/2 second to 1 second seems to be sufficient. The voltage, I cannot remember, it was 131. DTHC delay in seconds, we leave it set at 1 second. What that number is, though, is how long before we want torch height control to kick in. We don't want it to kick in instantly. We want it to actually come in after we've moved away from our pierce point. And again, we have found that 1 second works well. No DTHC, that's a feature that's very seldom used. If you enter 0 in here, regardless of what you do later on, this tool will never have torch height control. There is some cases if you're doing maybe some very exotic materials that you know very little about as far as feed rates, you might want to put 0 in there, so if you accidentally generate code with torch height control, it's not going to go all wacky on you. But for normal everyday cutting, you would want 1, because we definitely want torch height control. Back up at the top here, kerf width, I kind of skipped over that. That's actually in a different section of the manual. It's right before all of your cut information. You can see here, so our estimated kerf width in English, we were looking at 1/4 inch aluminum at 65 amps, so you would go across and you would see that the kerf width is 76 thousandths. Now this is estimated, so you might want to cut apart with new consumables and take a measurement. You might find that your kerf width is, your parts come out better at 73 thousandths. Automatically generating name, I'm not a fan of using that. SheetCam will base the name off the kerf size. Well, you have a lot of kerf sizes that are going to be the same or very close, and you're not going to have a clue what it is. So I highly recommend you enter your own name in here. Lead-in type, there's normal, ramp, and wiggle. We only use normal. On a rare occasion, if we're pushing the limits of a machine, doing material that really should only be edge start, you can use wiggle. You enter that and you give the wiggle size, and what it does is it moves the head while piercing to help prevent slag from or molten material from blasting up and getting up into the nozzle. Honestly, we have customers that say it works well. Not a fan of it either. I think that the plasma cutter manufacturer has a reason that they want an edge start on something. If you need to cut that all the time, then it really should probably get a bigger plasma cutter. It is useful for the once in a great while job on some thicker materials. Otherwise, you leave your lead in on normal. And that is all there is to setting up a tool. And once you click OK, you're going to have a new tool listed. Do recommend that once you create new tools, I would go to File, Save Tool Set As, and give it a name. Save it to a USB drive or somewhere. A lot of information to enter to only find out later that because of a computer crash or because of someone else's mistake or importing a tool or something, you lost them all. It's nice to be able to go right back and get what you have already entered.